So use the ratio test to test this series for convergence or divergence. So the ratio test states that if the limit is n approaches infinity of a to the n plus 1 over a to the n, if it's less than 1, it is convergent. If it's greater than 1, it's divergent. And if it's equal to 1, then it's inconclusive. So setting up our limit, we are simply going to replace every n value for our series with n plus 1, and then multiply by the reciprocal. So we can simplify this limit. So limit is n approaches infinity. So 3 to the n will cancel with this to leave us with 1, 3. And negative 1 to the n will cancel with this to leave us with 1, negative 1. So we can pull out our negative 1/3. Now we must simplify this further. So we can rewrite the numerator as n to the 1 plus 1 over n cubed over n cubed, and then further rewrite the fraction as all of this cubed. So the n's will cancel, and we will be left with the limit as n approaches infinity of negative 1/3 of 1 plus 1 over n cubed. So if we plug in infinity for this n, we'll be left with this, and anything over infinity is 0, so we're left with negative 1/3 times 1 cubed, which is negative 1/3, which is less than 1. So by the ratio test, this series is convergent. All right, question 2. So true or false, this series is convergent by the ratio test. So again, same thing, we'll set up our limit. Plugging in n plus 1 for every n value. And then multiplying by the reciprocal. So again, we can rearrange the limit. And from here, we know that this from the previous problem is equal to 1 plus 1 over n cubed, multiplied still by n to the 5th plus 1 over n plus 1 to the 5th plus 1. And so because of our properties of limits, we can break this limit up into two limits. So we know that this limit, if we plug in infinity, we will get out 1. However, this, we will have infinity over infinity, so we must use L'Hopital's rule, which states that the derivative of the top over the derivative of the bottom, if it gives us a number, then that is our answer. So the derivative of the top over the bottom, so the first derivative will equal 5n to the 4th over 5 to the n plus 1. So the 5's will cancel, and after taking the derivative, we'll end up with the 5th derivative equaling 1 over 1, which equals 1. And so we can multiply our two limits together to get 1 times 1 equals 1. So by the ratio test, this series is inconclusive because our limit equals 1. So false. Thank you very much.